Hello, everyone. My name is Calvin Rimsberg, and I'm a sales engineer for Juniper Networks based out of Houston, Texas. And it is this distinct honor to be able to share with you, my fellow network engineers, an introduction into Python programming. Now, Python is one of those really rare programming languages that manages to be both relatively easy to learn, but also have this capability to scale to the ultimate level of complexity. So it doesn't matter if you're just writing a script that will change a router's host name, or if you're building an entire artificial intelligence like Juniper's Mist. Python is a single programming language that can, in theory, do it all. But probably more appropriate for those of us that live within the IT infrastructure world, Python has a rich package ecosystem that allows us to import snippets of code that handle some of the more complex tasks. Things like managing an SSH connection to a router, how to send a command to a remote device and then store the data that's returned. My hope is that by the end of this course, you'll have an awareness of the foundations within Python programming and will have some real world experience into building a practical network automation script. So what exactly are we going to be doing today? Well, today we're going to be building a software compliance tool within Python, something that will prompt the user for their username and password, and then we'll use that information to log into each of our firewalls and tell us whether or not that firewall is running the certified golden image from Juniper. And in order to do that, we've got to cover a few topics within Python. Well, there's the obvious. We need to install Python. But then we're going to transition to more of the concepts within Python. Things like what are data types, where we'll discuss things like strings and integers and lists and dictionaries. Then we'll talk a little bit about how to install and import some of that ecosystem packages that are out there. Remember we talked about managing SSH connections and all that type of thing. Then we'll cover the basic foundations of loops, and then we'll wrap it up with conditionals, where we talk about how to compare different values, which will be really important when we want to compare our certified golden image with that of what's running on the device. So without any further delay, let's go ahead and start with the installation process on our Windows, Mac, and Linux machines. So let's start our installation process with arguably the most complicated one, which is installing on Windows. Now, traditionally, it's been pretty difficult to get a developer environment set up within Windows, but things are improving in the Windows world. There's a technology out there called WSL2, which allows you to basically run Linux inside of Windows. It's a phenomenal piece of software that's provided by Microsoft. We're not going to go down that route because it's a little bit more than I wanted to really cover today. Instead, let's show you how to install Python on just a vanilla Windows 10 installation. So I'm going to move over into my Windows install. I've got one thing that I've installed in here, and that's just a different, more secure web browser. Let's go ahead and open up our command prompt by typing in CMD either at our search bar or from the run menu. And if I type in the word Python and hit enter, I'm not going to get the Python shell. If I do not have Python installed, Windows 10 will automatically open up the Microsoft Store here and ask you to install through this. Now this might work. I don't know. I've never done it this way. I'm sure Microsoft has got, all their I's dotted and their T's crossed, and that this works exceptionally well. But I'm going to show you the more conventional way of doing things, and that is by opening up your web browser, and then typing in python.org. From here, we're going to download the latest version of Python, which I believe is 3.9, and it is. So let's hover over this downloads menu, click this button that says Python 3.9, and we'll hit the save button. Now from there, we're going to follow the traditional Microsoft installation process, which is a bunch of next, 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 done. But there's one thing I want you to include on here, and that is this bottom check mark here. This should be by default. I don't know why they didn't do this. But let's say add Python 3.9 to the path. Now, if you're unfamiliar with what, systems and how they work, the path is basically a list of directories for the system to look in whenever you type in a command. It's a very poor way of saying it, but whenever I type in Python, if we did not add it to the path, the Windows operating system wouldn't know to look in the specific directory that our Python is installed. So clicking this is very good. Let's go ahead and click this install now, where we'll get prompted and we'll just say yes. Keep in mind, this is the more difficult of the installations across the operating system. It's even easier on Mac and Linux. And once this is done, there will be one more option here for us to disable this max length parameter. Now, this is a Windows only thing. I don't know if I really want to call it an issue, but Microsoft has a limit of characters that you can have within the path. And here it is right here. I'm just going to go ahead and select this, disable the path limit, length limit. You don't need to. I don't think you're going to run into this problem. But let's just go ahead and do it and say yes. And just like that, Python's installed. If I close out of my shell or my command prompt and I open it back up, that, by the way, will help refresh the path, right? If I had not opened up my terminal and then hit the Python term again, the path would not have been updated and would probably open up that Microsoft Store again. But now that we've got a fresh session, let's go ahead and type in the word Python. And now you can see we are in the Python interpreter, also known as the Python REPL. And from here, I can just go ahead and exit by typing the word quit and doing an open and close parentheses. That'll take me out of the Python REPL. So that's how to install Python on a Windows machine. You probably didn't need a video tutorial on that. Let's also install VS Code. Visual Studio Code is the IDE or the text editor that I'm going to be leveraging in order to build all my Python scripts. Not only does it give you the really nice text editor look and feel, but you can also run Python within the actual text editor itself, so you don't have to work from the command prompt anymore. So very nice. In addition to that, there's all kinds of features and extensions within Visual Studio Code to help you work within Python. They'll have linters that can help identify where your code is broken before you try to execute it. There's even extensions to help Juniper syntax so that you can actually see Juno's config with nice highlighting of keywords. Really, really nice. So I'm going to go ahead and say I accept the agreement. You guys saw me read all those terms of services, right? Let's go ahead and do next, next, next. And I'm going to add I'm just going to go ahead and click all of these. These are good. Look at that. Add to path. It's already there by default. And let's click the install. This is going to install our text editor that we're going to be working from. I will not be working from a Windows machine since my company laptop is a Macintosh, but I hope this part has at least been beneficial for you. Let's see, there we go. There's our Visual Studio Code. This is our text editor. From here I can say, let's create a new file, and let's see if you can see, let's move my face. There we go. From here I can change the language of the file from plain text. I can just type in Python, and now my text editor will understand Python language and provide some syntactual highlighting for me. And if I want to enter the Python terminal directly from my text editor, I would just go up to this terminal window right here and say new terminal. And then here I'm given my Python terminal right here. So this is a shortcut, allows you to execute your Python code directly from your terminal. We're going to be doing that extensively back on the Macintosh version or the Mac OS install for me. But for my Windows 10 enthusiast out there, this is how you go through the installation process for Windows. I hope this part has been beneficial for you. Now, for my Macintosh users, my Mac OS users, let's go ahead and go through the install. And there's a little bit of good news and a little bit of bad news. So let's just show you. If I open up my terminal here and I type in the word Python, I'm not going to get the Windows store that pops up. In fact, I will actually get the Python REPL, the interpreter. But for the bad news is that the version that ships with Mac OS is extremely outdated. It's EOL. It's been EOL for quite some time, I believe. So Python version 2. As you saw on the Windows install, the latest version was 3.9.1. So a whole major release and several minor release updates on there. And they unfortunately aren't backwards compatible. Just kind of like IPv4 and IPv6, not really backwards compatible without some kind of translation happening. But unlike IPv6, the world has kind of wiped their hands clear of Python 2 and everyone's kind of moved on to Python 3. So although my operating system still uses Python 2, shame on you, by the way, Mac, we need to go ahead and install Python 3. So the installation process is, you can go either way on this one. You can follow the same path that we did, which was to go to python.org, hover over the downloads, download the package, and run through the installer. Or if you are using the homebrew package manager for your Mac, you can also use that to install Python 3 from the terminal. Now, if you're familiar with homebrew, and you would know whether or not you have it installed because it doesn't come by default. Only thing that you need to do to get Python 3 installed with homebrew is to, let's return to our terminal here. Let's see here, would be to type in the word brew install Python 3. Now, in my case, I already had Python 3 installed through Homebrew, so it's just going to let us know, hey, it's already installed. Don't worry about it. But back into my installer here, or let's see, here's the path. It looks like Python 3 has now been successfully installed. Right here, we'll just close out the window, say move to trash, and open up our interpreter again. Let's just go ahead and clear the screen, and I'll type in Python 3.9. Let's see, there we go. And I get Python 3.9. The REPL is now right here. So really, really easy to install. Sorry, it's supposed to be quit and then open close parentheses. That will be a very common mistake that you run into, by the way, when you're starting out with Python and you're trying to leave the Python interpreter or the Python REPL. Make sure you type in the word quit and then close, open and close parentheses in order to do so. And I'm happy to report that the Linux installation process is even easier than all those that we had before. For those of you that use Linux on a regular basis, you're probably not too surprised to hear that. So let's go ahead and transition. This is a vanilla Ubuntu 20.0.4 install. For us to install Python 3 and all the packages that we would like, just go ahead and type in sudo apt install python 3 -dev so that we get the developer package of this, Python 3 -vim, so that'll help us do virtual environments, and Python 3 what was the last one? Pip. There we go. And pip, if you didn't know, is the Python package installation tool that we'll be using extensively for installing external packages in Python. Let's go ahead and enter my super secret password. Hit the Y letter for yes. And we should be good to go. So if I clear my screen, type in Python 3, now I get my Python interpreter. Now you notice that I'm using Python.3.8.5. This is not really my doing. This goes back to the fact that the Linux operating system has a source of repositories that it pulls from, and in that master list of repositories, the version of Python 3 that's in there is 3.8.5. That's how we landed on this. If you'd rather pull down 3.9.1, go ahead, Google it. There's plenty of really great resources to help you install that version. We're now equipped to transition into the Python world. And the very first thing I want to cover is data types. When we create an object in Python, it's going to be associated with some kind of data type, whether it's an integer or it's a string or it's a list or a dictionary or something completely different. And I think that's probably the best place for us to start. Let's go ahead and ditch PowerPoint and just jump right back into Visual Studio Code. I will open up a terminal session and I will get into the Python REPL by typing in the word Python 3. All right, So, what is an object in Python, anyways? You can, or at least I like to, think of an object as kind of like an empty box, like an empty cardboard box. You might use boxes like this to move, to a different house location, or maybe you're just storing some things inside of the attic. But the idea behind the box, I can't believe I'm explaining this, is you just store stuff in there. It's usually common things, like maybe you have a box that's just baseball cards that you used to trade as a child, or maybe it's full of basketballs, or maybe it's full of old science fiction novels or David Bowie LPs, or whatever it is. But it doesn't have to be a common thing, right? Boxes, you can store all kinds of things, nail polish with LPs, doesn't really matter. The same is true whenever you create an object in Python. This can hold either a switch configuration, maybe an object will create a firewall policy, maybe it's just a host name of a firewall. It doesn't really matter what you store within it. However, when you create that object, Python will try its best to infer what data type that object is. So let's go ahead and start giving you some examples so you can start kind of putting this together within your head. I'm going to go ahead and create my first variable in Python by calling OSPF and setting it equal to the value of 10. Now, in the Python world, as you can see, for us to create a variable, you declare the variable, you separate it with an equal sign, and you give it the value. In this case, I've given it a value of 10. Now, Python will look at that and say, 10. 10 is a number. So Python will automatically infer that this type of object is an integer. And we can validate that by typing the word type and passing it in a parameter into parentheses of the object name. In this case, it's OSPF. When I hit the enter button back, Python lets us know that, hey, Python thinks that OSPF is an integer, which is great. Now, if I created another object here called BGP and set it equal to 20, let's just go ahead and pretend that these are the amount of routes in each table. Now I've got two objects, an OSPF object equal to 10, a BGP object equal to 20. And because they are integer types, we can perform basic arithmetic, addition, subtraction, multiplication, division, etc. So let's go ahead and say BGP plus OSPF. If I hit the enter key, what do you think will be the return value? If you said 30, well, I want to first off congratulate you for having a first grader's level of basic math skills. You should be proud. 30 is the correct answer. We've added the BGP object with the OSPF object, which is effectively 20 plus 10, and we get a response back of 30, which is great. Integers are fantastic. It allows us to do a bunch of really great things, and then will definitely be a really important part when we start looking at operations in the networking world. Now, what about the string values, right? What is a string to begin with? Well, you can think of a string as just basically a collection of text, right? So for instance, we'll create an object called hostname, and we will use the quotes. We'll actually wrap our value into double quotes here. I'll call this hostname router1. Now, router1 is not an integer because it is text. It's a combination of actually text and an integer at the end, but in the Python world, that is all considered one thing, which in this case is a string. Let's go ahead and use the type function to validate that Python inferred this correctly. And then we get the class that returned back, or the object type for this instance for hostname is a string. Now you cannot do basic arithmetic with letters. I don't care what level of algebra that we were talking about. In this context right now, I could not, for instance, add hostname plus OSPF and expect to get something that comes back. In this case, Python REPL returns back and says, hey, there's a type error. It's a data type error. We're trying to do an operation of adding a string plus an integer, and there's a conflict there, right? So I hope that provides a little bit of clarity. The two primary data types that we're going to talk about right now, integers are numbers, and because they're numbers, we can perform kinds of operations on them, basic arithmetic. whereas strings are a collection of text. Either it's a host name, an interface config, whatever it is, that is the type of string. Now, let's give you a little bit better of an example here. This time, let's go ahead and create a new object and set it equal to the combination of our OSPF and our BGP table. I'm going to create a new object. I'm going to call it routing table. I'm going to set it equal to BGP plus OSPF. Now, we've got this routing table object. You'll note that it didn't return back the value immediately within the Python REPL. The way that we can get insight into that is we can either type in the name of the variable. Let's see, type it in correctly. Just type it in to the REPL and we'll get the immediate value back, which is 30, which we kind of guessed because we did that operation up here. But that really only works inside of the REPL. When you're in an actual Python script, what you'll need to do is use the print function that's provided by Python to print out the value to the screen. So let's go ahead and type in print routing table right here, and you see that we get that value coming back as well. So again, the idea here is that we've got these objects or variables. Inside of that object, there's data, and then Python wants to know what kind of data. What's the type of data? Is it an integer? Is it a string? Or is it something else? And based on what type of data it is, allows it to perform a necessary type of function. Now, moving over into the world of lists. Now, lists are going to be your friend whenever you need to create an object that stores multiple objects within there. So again, going back to that context that an object is just an empty box, you might store more than one thing inside of that object, but you still need it to represent that single box as a full entity, despite the fact that there's multiple things within there. And probably most appropriate for us in the networking world, let's think about this in terms of devices, right? We have a network. There's usually more than one network device, but we want to reference all of those devices at once. So how do we do that in Python? We use the data type of a list. So let's go ahead and let's do an example. Let's create an object called devices, and I'm going to set it equal to a list of devices. And the way that we create a list in the Python world is we use an open and close square brackets. And then we'll store all of our objects inside of these square brackets separated by comma values. So for my first device, second device, and third device, we'll go ahead and start filling these in. So I'm going to have wharf.ds9.com. I'm going to have cisco.ds9.com, and we'll have dax.ds9.com. Now these are three separate unique devices that are stored and represented as a list name devices. So again, extremely powerful list allow us to store a bunch of stuff in there and then represent all those objects by just calling out the name of the object. In this case, it's devices. Now, a really interesting thing to note, and this will make sense if you're coming from a Juniper background already, is that since a list contains multiple objects, there will be times where we want to grab a specific object within that list. For instance, if I wanted to reference the cisco.ds9.com device, how do I do that when it's within a list? Well, the good news is that there's something that we call an index, basically saying each object within this list is represented by an integer. Now, here's where things get a little bit confusing if you're not coming from a Juniper background. In the Python world, and actually I think all programming world, every number or every number system in programming will start with the number 0, not 1. All right, really important to kind of get your head around that. So if I wanted to, and let's just go ahead and talk through this, wharf.ds9.com is my first object in this list. It is not the index of 1, because remember, in programming, we start with the index of 0. So 0 is what wharf.ds9 is called. And if I wanted to, let's say devices, and I'll pass the index of 0 here, again, by using the brackets, I get back right in my interpreter, wharf.ds9.com. If I wanted that Cisco object, I would hit the up arrow and I would give it the second index, which is the number 1. So this is a little bit, it takes a little bit getting used to. Again, in the Juniper world, everything that we do is very programmatic. It's very developer friendly. So our interfaces start with the number 0. In case of Python, we operate that same way inside of a list. So I hope that makes sense a little bit. In that list, again, collection of different objects. Each object is represented by an integer, and we start at the number 0 and scale up to the number of infinity. I hope that makes a little bit sense. Let's now transition and talk about dictionaries. Dictionaries are great for storing complex structures of data. And a really good example that I think we're going to walk through here would be probably something like a BGP configuration. We're going to encapsulate our new object. We'll call it BGP config. But instead of, like with a list, we used the square brackets, open and close. In a dictionary world, we're going to use the curly braces instead. And this time, we're going to be creating a series of key value pairs. Now, if you're not familiar with the term key value, basically we're going to create an object. We're going to give it a name. That object's name is going to be represented as what we call the key, and then we're going to set the value of that object, and that's basically how we develop these complex structures within a dictionary. Doesn't really sound like it makes sense, so let's just go ahead and walk through it. If we're talking in the context of a BGP configuration, we may have a key value pair. Let's say a key would be maybe my neighbor IP address, and I'll set that equal to, we'll just say 1.1.1.1. Let's make sure that we've got that encapsulated correctly with the quotes. All right. Then we'll create a new object similar to a list, separated by a comma. But remember, everything inside of this dictionary is in the format of a key value pair rather than just a value. So maybe my neighbor ASN is going to be set equal to the value of 6,500 or 65,000. As you can see, that was an integer because there's no text within there. And then maybe I want to set my local ASN, and we'll set that to a value of 65,001. So again, this concept of a dictionary, it allows you to store complex data structures underneath a single object name. And it really kind of helps with this concept of a BGP configuration or an interface config or whatever. You can look at an entire device configuration as a series of key value pairs. Host name is equal to router 1. Loopback 0 IP address is equal to 1.1.1.1. Whatever. Everything within that we do on a router configuration or a switch config is basically just a series of dictionaries, a bunch of key value pairs everywhere. What makes, though, the power of a key value type of mechanism so flexible and so easy to work with, let's say, for instance, I wanted to know what my local autonomous system number was anywhere within my Python script. All I would do is I would type in my object, my dictionary called BGP config, and then I would pass in a key asking for the value of that key. In this case, we'll type in the key of local ASN. Now, if I hit the enter key, what do you think will be the value that comes back? I don't have the Jeopardy music in the background, but let's just pretend it's playing here. Think about this. I'm passing in a dictionary and I'm saying, give me the value of the key local autonomous system number. When you look at all the key value pairs here, the one that you should have said is 65001. That's exactly correct. So think about this for a little bit. Think about the power of dictionaries. again, you could build an entire router configuration and have everything stored as key value pairs. That will that power should be quite evident, like right off the gate. But this will definitely play into a different way of managing our networks. It's a more advanced topic, but when we talk about infrastructure as code, what we're really talking about is extrapolating a router or switch configuration and setting it to a series of key value pairs stored inside of some kind of dictionary. When you extrapolate a router config and just separate all the syntax stuff, a Cisco device, an Arista device, well, those are kind of the same. Like a Cisco device and a Juniper device, for instance, the syntax is wildly different. But at the end of the day, there are parameters that we set. There's values that we set. Here's the value of my host name. Here's the value of my BGP neighbor IP address. If you boil all that down, it's really just a dictionary key value pair system. And now you can manage that into some kind of external source code repository like GitHub or what have you. And then all you need to really do is just run those key value pairs against some kind of template, maybe a Cisco config template or a Juniper config template, and get the full configuration for your device. So again, infrastructure as a code is a more advanced topic, but just kind of think about where dictionaries lay in the context of a configuration or operation, and the power should be pretty evident. So with that, we're going to wrap up our conversation around data types. We talked about strings. They're basically a collection of text. It's a single object. We talked about integers. They are numbers that allow us to do basic arithmetic. We talked about list, which is a collection of different variables and values stored within there. And then we talked about dictionaries, which are similar to lists. It's a single object that will sometimes contain multiple objects within there, but they're separated with a key value pair that allows us to reference that value by calling it key, like what we did here. So next, we're going to talk about the Python package ecosystem, how to install packages, how to import packages, and we'll do our very first network automation interaction where we interact with a firewall programmatically through Python. So let's move on to that next section because it's going to be a lot of fun. One of the very first things that I had talked about as far as benefits of using Python is the rich ecosystem of libraries or packages that exist out there. These packages allow us to import very mature code into our script to kind of shortcut the development process. As you can imagine, developing an SSH driver in Python is not necessarily a introduction to Python type of material. So let's go ahead and leverage what Juniper has provided by installing the PyEasy package. And the best place for us to look for this is actually back in our web browser. There is a web page called PyPy, PYPI. .org. This is the official Python package repository. It is accessible through the command line by using the pip keyword, pip install, and whatever the name of the package is, or you can just browse and find whatever kind of packages that you're looking for. In our case, we want to install Juniper's PyEasy, which is a Python library that helps us interact with the netconf API on all of our Juniper devices. So I'm going to go ahead and search for Junos Easy NC, Easy netconf. I hope that kind of makes sense. And we can see at the very top here, we have Junos Easy Automation for non-programmers, which is us, right? We're network engineers. This isn't our primary role in life. And so from here, we get the immediate installation steps required. All that's required for us to do this is to run this from the command line. Now, when you installed Python, you automatically installed pip, which is a program. It's not a program. It's a command line tool to help you install these Python packages and manage them within your operating system. The only exception was on the Linux one where we had to specify Python 3-pip because it doesn't come with the native Python package in Linux. So now that we've copied this command, let's return to our terminal. Let's open up a new terminal. And let's just go ahead and paste it in here. Pip install Junos easy nc. That is the admittedly the unfortunate name. I really wish we would have just called it PyEasy like it's commonly known as. But okay, so this is kind of interesting. I get an alert from my terminal to tell us that the command pip was not found. Now that's because we installed Python 3, so the actual pip command should be pip3. Now we can see that that's going ahead and executing. It's reaching out to the worldwide internet, or specifically to the PyPy resource. And here's a really interesting thing to note. There are packages that are found on PyPy that will have dependencies on other packages. So in the case of us installing PyEasy, it's not just simple enough to just install PyEasy. PyEasy depends on packages like LXML for helping us work with XML data, NCC client for helping us manage netconf connections through Python, cryptography to help with the SSH, Markdown, blah, blah, blah. There's all these different types of packages. Now we installed all of those just with that single command, and we get the response right here. As you can see, we installed all of these just by typing that single command. That's great, and that's the way that we probably want it to be. But just know, just because you're installing one package doesn't mean you're going to get that one package. Sometimes that package has dependencies. In this case, there were several dependencies that PyEasy had automatically installed. Now we can validate the packages that are currently installed by typing in pip3 and the word freeze. Now I don't know why they called it freeze. If anyone out there has got a bigger brain than mine and knows why freeze of all words, well, then there you have it. But pip3 freeze will give us a list of the Python packages that are installed. The one that I really care about right now is Junos easy nc, which is the package name for PyEasy. My friends, it is time that we graduate away from using the Python REPL. And in this, our first network automation script, we will actually be using Python files. So congratulations if you made it this far. You have now certified Python REPL expert. But in order to help maintain my development and all the typing errors that I make, it's easier for me to start working inside the context of a text file. So within Visual Studio Code, I'm going to start by saying create a new file. And let me just go ahead and save this file. We'll save it to my desktop. We'll call this Python, or no, let's not call it anything called Python. Let's just call this compliance.py, because our script will ultimately be performing the role of a compliance tool. So I've got compliance.py that's created. One thing that you'll note right off the gate is that your text editor, Visual Studio Code, automatically gives you a nice little icon here for the Python logo. It detects that this is a .py extension, so that it expects this to be a Python script. That might not sound like a whole lot to you right now, but what's great about it is that we'll start to get a lot of the keywords in Python will start to have different colors, and that will help us identify exactly what is what within our script. So definitely help with the development cycle. I'm going to close out my terminal window, and let's now focus on the next important thing, which is getting Visual Studio Code to point to the appropriate Python version on our machine. In my case, that's going to be at user local bin Python 3. And this will, again, help us identify the appropriate Python packages that are installed. Now, if I open up a terminal, I should automatically be within there, that user local bin Python 3. If I do pip3 freeze, I should still see my Junos easy nc packages, and I do. So Python PyEasy is now installed and it's available, so we're good to go. Now, the first thing I want to do is I want to import the Junos or the Junos PyEasy package into my script. The way I'm going to do that is I'm going to type in the word from. Now, this is a way of saying from this package import this function. So in our case, to point to the PyEasy, it's JNPR. And look, my text editor is trying to help me. It's trying to let me know what packages are available for me. And you can just hit the enter key for auto completion. So juniper.junos import device, right? So what we're doing is we're actually importing a data type, a custom data type from the juniper.junos package, which again is the PyEasy. I apologize that the terms are a little all over the board, but when I call jnpr.junos, I'm calling the PyEasy package. And this time I'm bringing in a class or an object type of device. Now, again, what's great about Visual Studio Code is that if you hover over things, it will help kind of bring some kind of context into what it is that you're looking for. A little bit more of advanced topic to get into the description, but again, it's a really nice value add for you within your script. So just like that, we've imported this function or this device type or this data type called device from the PyEasy package. Now, what does that really do? On surface, it does nothing by itself. What PyEasy is going to expect us now to do is to create a new object and then pass it certain parameters into this device data type. So let's go ahead and let's create an object. I'll call it connection, and I'll set it equal to device. And this is, again, this is what we had imported from the package. And then here, I'm going to pass some key value parameters. The host is going to be called alderon.dmz.home, which is the name of one of my firewalls. The user is going to be set to the name of automation. And then the password is going to be equal to Juniper123. So again, the device was something that we imported from PyEasy. It's basically a shortcut for giving PyEasy all the parameters of your network device. Now I've passed in my parameters. The name of my device as host, the user will be automation, the password will be Juniper123, and I've stored those into a new object that we call connection. Now what we'll do is we'll go ahead and we'll call connection.open. Now this is a function of this device type that we imported. That's going to open up the netconf session to our device over SSH. So connection.open is going to open up an active SSH session. Now we're going to go ahead and let's run a command. I'll create an object called show version where we're going to go ahead and issue an RPC. So connection.rpc get software information. And then even in there, I'm going to pass another set of parameters. And it's just because I want the format of this to be in JSON. So just like you can on a Juniper device, where you say display XML or display JSON, we can actually replicate that functionality here within our remote procedural call, which is basically, in this case, get software information is directly mapped into a show version. And I'll show you really quickly after this how we actually found that appropriate RPC call. But the next thing I want to do is I want to go ahead and I want to close that netconf session. I don't want my Python script to just leave a bunch of SSH sessions active in the background, because as you know, as a network engineer, TCP has no timeout value associated with it. So if you don't close the connection, it'll stay there and it'll persist until some kind of event has effectively closed it out. Now, finally, what I want to do is I want to print the value of show version to the screen. So that's it. Effectively 9 lines of code. and some of them are just empty spaces. So let's talk again through this really quick. We're importing the PyEasy package, which happens to be called jmpr.junos. And inside of there, I'm importing a device or a data type called device. Now that ships with PyEasy. It's a bit of what we call like boilerplate code that allows you to manage a device's connection. And now we create a new object called connection. We set it equal to that device type of device, or that set it equal to the data type of device. But we also pass in some parameters about my device, the name of the device, the username, and the password. We then open the netconf session to the device by passing in the function of open. And here Visual Studio Code is kind enough to give us some information about what the open function does. Once the connection is open, we're going to run a remote procedure call, or an RPC, on the device. And in this case, we're saying get software information, which is a programmatic way of saying show version. And I'm passing in some extra parameters in there to say, give me back the data in the format of JSON. Now, this can absolutely be a format of text, where it'd be just like it is on the screen, or format of XML, if you like working with XML. Actually, the format of XML, just trivia notes, is the default, because as you know, in Juniper, everything that we do is already in XML. So the data type we would have gotten back is in XML. But working with XML is a whole other conversation that we'll get to in a different type of session. Then we close our netconf session to the device, and then we print the output to the screen. That should be everything that's needed. So let's go ahead and open up a terminal window again. And this time I'm going to change into my desktop, and I'm going to say Python, Python 3, and then the name of my script, which is compliance.py. Let's see if we're successful. Let's hit the enter key. And the fact that it didn't immediately error out is a little bit good news, believe it or not. So what we're doing right now is we're going through the connection, we're running the command, closing the connection, and then we print it to the screen. Now, as you can see, the data type that we got back looks like it's in the data type of JSON. It's actually, PyEasy actually goes a step further and converts that format of JSON back into a Python dictionary. And again, we haven't talked about JSON yet, but just know that JSON is a data format, and it's interchangeable with Python dictionaries. It's a lot of fun to work between the two. In this case, PyEasy took the JSON and returned the data back into the format of a Python dictionary. So very, very helpful, very useful. If we had excluded the format of JSON and I just issued it like this, this will still work, but the data type that will come back will be a XML format. And unfortunately, working with XML, you need to know that it's not something that you can just print out to the screen as simple as we did here. In this case, we got an element that came back. This is an element within the XML data object that really doesn't give us the information. It's there. It just, XML requires us to do a little bit of digging. It's not as easy to work with as JSON. But again, really, really easy for us to issue remote procedural calls and get some feedback back from our devices. All right, so we're in a pretty good position. We have a piece of software that can log into a firewall, run a command, and print it out to the screen. Great. That works for one device. How do we scale? Well, there's a couple ways. There's a really, really bad way, and then there's the appropriate way, which is involving loops. But for us to kind of go down the discussion of loops, let's first show you the really bad way of doing it. So let's return back to our text editor here. And you can see that we've got all the parameters set up to issue the commands against a single device. This works well. But if we wanted to execute it against 3 devices, well, the wrong way to do this would be to copy and paste and just change the name of the device each time. So Hoth, and then we'll call this one Deep Space 9. And this will absolutely work. And if you have only 3 devices and this is your script, hey, I might turn my head and look the other way and say, yeah, that's fine. But rare. It's rare when there's a network engineer in a company and there's only 3 networking devices. More often than times than not, there's dozens or hundreds or even thousands of different networking devices out there in the environment. How could you get this thing to scale? You're obviously not going to copy and paste for every single device. That's where the construct of loops really come into value. So in order for us to work with loops, let's first revisit the data type of a list. Now, as you recall, a list is a object that allows us to store multiple things within there, whether it's records or drinks or whatever it is. In our case, we're going to create a list that hosts our inventory. I'm going to call this list a devices, or we'll call it devices. And as you recall, in order for us to create a list, we use the open and close square brackets. And then we store each one of our devices within these brackets and we separate them with a comma. So in this case, I have 3 devices. I've got Alderon, I've got Hoth, and I've got Deep Space Nine. Let's go ahead and add those in here. Let's paste Deep Space Nine. All right, now I have a list of all 3 of my devices in my environment. How do I run this snippet of code against each one of the devices? That's where the concept of the loops really starts to shine. So what we're going to do is we're going to create something called a for loop. And inside of that for loop, we're going to execute this code that we've got typed between lines 6 and 12. We're going to run it against every single instance of an object within that list. So in order for us to create a for loop, what we're going to do is we're going to type the word for, and then we're going to give it a temporary ephemeral variable name. I'll just call this for firewall in, and now this is where I point to my list of devices. And you can see my Python, my text editor is trying to help me. It's trying to give me a little bit of hint as to what it is I want to do. So I'm going to say for firewall in devices, right? This right here is my list. And I'm saying for every single object within that list, let's run this certain code against it. Now, Python it's not unique in this, but it's an important thing to understand. Python is one of the programming languages that's white space sensitive, meaning that the indentation level that you have set tells Python what is nested under another object. In this case, I've got a for loop and I want some code nested inside of that loop. So the way that we do that in Python is that it's 4 spaces, not tabs. Don't be the person that uses tabs. 4 spaces indicate that something is nested underneath something else. In this case, we've got a for loop and I'm nesting in some code underneath there. So let's just take our code that we had developed previously and make sure that it's appropriately nested inside of there. And we'll move it just like this, and that should be good to go. Now, I need a way of telling my code right here which device we're currently working for. And since we're looping through our list, we're just going to reference the ephemeral variable name right here that I used the word firewall. And that will become what we insert as our host. Now this right here is all that's required for us to take our previously functioning script and then loop it over multiple devices. So the output that we see on the screen should be the same exact that we got earlier, just with a lot less amount of code. So again, what we're doing right now is we're looping over the devices list. We're picking on the first one first, which is alderon.dmz.home. We're opening the SSH connection and running the netconf RPC. We're printing it to the screen, closing the connection, going on to the next one, doing the same operations, closing the connection, then moving on to the final one. Again, just basically 2 lines of code where one was where we created the list of the devices, and two where we created the loop, allows us to scale this up infinitely. So if I was to add another device into here, let's say Tatooine.network.home, this script will continue to operate. I don't need to refactor it. I don't need to make any additional changes to my for loop. It doesn't matter if there's one device in this list. It doesn't matter if there's 100,000 devices in the list. This code will continue to work. Obviously, you can see just how powerful this looping mechanism is. So I hope that helps you. Again, there is another concept of a loop called a while loop. But in order to understand while loops, you kind of have to understand the section we'll cover later on conditionals. And again, while loops, they have their purpose out there in the wild, but not nearly as common as for loops. Again, the idea behind the for loop is that we're going to run a snippet of code against all the devices within a list, and that's going to make our lives just that much easier. So there's something terribly wrong with our script right now. And it's not that it doesn't work. It definitely works. The problem is that the username and password are hard coded into the script, which is in clear text, which will probably be pushed to GitHub or GitLab so that the whole world can see it. So we obviously don't want that to be the situation. We would rather that the script prompt the user for them to enter their username and password and then use that information to handle the logging in into our devices. So Python ships with some built-in functions. One of them is called the input function. And what it allows you to do is whenever the script is ran, it will prompt the user for whatever value to be associated to an object. So in our case, let's go ahead and let's create a couple new objects. One of them is going to be called username, and we're going to set it equal to the result of this input function. Now the input function takes a argument, and in this case it's asking us what kind of question would you like to prompt the user. And we would say, hey, please enter your username. Okay, admittedly that's not a question, but this will be what's actually printed out to the screen. And let's copy and paste that and say password will be equal to please enter your password. Now, whenever we issue the script again, it's going to prompt us first for the username, and anything that we type in on the keyboard will be saved inside of that username object as a string. Really important that you understand, if your username just happened to be a number, it will still be stored as a string. That is the default for input. Just important to remember. And then after we've received that input data and stored it as the username, it will repeat the process for our password. And then what we need to do to acknowledge or to leverage this information is to change what we pass into the device type from the Juniper PyEasy object. In this case, we'll just say user will be equal to whatever we stored into the username object, and password will be equal to whatever we stored into the password object. Now, just know it doesn't have to be, we don't have to call this username and password. I could call this vanilla ice cream cone, and the password could be called pineapple upside down cake. It doesn't matter. It's just this helps us understand a little bit more if it's directly in line with the function that it performs. So let's save our script and let's run our code again. So we'll say Python 3 compliance.py, and now we get prompted, please enter your username. In this case, we'll type in the word automation, and then please enter your password, and this will be Juniper123. Now the Python script will use that information to log into the devices over that netconf API, issue the RPC calls, and we're good to go. Now every time this script is issued, this prompt will be given so that no sensitive information is stored within our script. Now, if anyone's watching over your shoulder, they'll say, automation user, I see that your password's Juniper123. And there are packages in Python that will help you manage protecting your password from showing up on the screen. That's a whole other conversation, but just know that there are other packages that allow you to do what we did with the input, just won't put whatever you type out into the screen. But as you can see, the input function allowed us to pass in our username and password, which removed our sensitive information being stored within the Python script, so that now everyone in our team can use the script successfully without having to worry about that username and password information being leaked. So let us wrap up this introduction to Python and talking about conditionals and where they play into fit. Now, in the real world, humans commonly evaluate a situation and then take an action based on the results of that evaluation. For instance, if it's below freezing outside, I might take the action of putting on a coat before I walk outside. Or if I'm headed to the beach for one reason or the other based on my complexion, then I know to bring a high SPF sunscreen and my bathing suit. So these types of logical operations are extremely common in our day-to-day life. Probably happens millions of times without us even knowing it. But that type of logic isn't inherently available within the Python code. We have to develop it ourselves. And that's where the role of conditionals come into play. In our specific use case, we're trying to evaluate whether or not the firewall's operating system is the golden image of our company, whatever we've established that as. So what we need to do is we need to have some kind of evaluation criteria embedded into our script to say, hey, we see the version of code. Is that equal to what is our golden image? And if it is, take this action. And if it's not, take this action as well. So the thing about conditionals to know is that, for one, they are what helps us incorporate some type of logic within our script, but that the result of an evaluation or the result of a conditional is always going to be a true or a false. Is this exactly as it should be, or is it something different? Now, that's not to say that you can't have additional evaluation criteria within a single Boolean or a single conditional. You can absolutely do that. But in our case, we're just going to be evaluating, is the operating system running the golden image of our enterprise, or is the device non-compliant? So in order to incorporate this type of logic, what we're going to do is we're going to create an if statement within our loop that we had created. And if in that evaluation, basically it's going to say, if operating system is equal to this, then take this action. If it is anything other than this, then take this type of action. So to better kind of flesh out this concept, let's go ahead and jump back into our code to reevaluate what exactly is going to be inserted into this program. So here we are, we're within the loop. At this point within the code, we know exactly which version of operating system we have available right now. Now, we are also getting a lot of extra data within this RPC call. We're getting things like the key value pair. The key is software information. The value is a list of things. And embedded in that list, there's other key value pairs. So we're going to have to do a little bit of digging to get exactly the object that represents the version of our device. And once we have that, then we'll be able to intelligently say, yes or no, this is exactly the version that we want to do within our conditional. So first, let's build our conditional. Actually, you know what? Probably more appropriate. Let's first dig into the RPC response that comes from our device in the format of JSON. And that is this show version object. So we know if we type in print show version, we get the full Monty. We get everything available for us. But again, we really only want a specific object within here, which is this version of code right here. So how do we get that? There's a couple of ways. Let's just kind of shortcut the process by jumping back into our web browser, and let's go back to the Python prettifier. And I'm going to go ahead and paste the payload right in here. I'm going to hit this format. And this is, again, this is just really for us to help us understand exactly kind of what we're working with here. We know that we're working with a dictionary because we see the curly braces. That tells us the object itself is a dictionary. And we have a key in that dictionary called software information. So right off the bat, I know the very first thing I need to do within my show version is to look inside for the software information key. So let's go back to our script here, and we'll say print show version, and then we'll ask for the key of software information. Now, when I run this script again, and we'll run it and I'll actually end up canceling it after the first device. Let's go ahead and say automation, Juniper123. What we're going to get back is all the data that was within this software information key. Now in our use case, all the information was still embedded within there, and that's just fine. Let's go ahead and cancel out, and let's look at the first object. I just didn't want this to run 3 times against all the devices. Now when I look at the object, I see that I'm working with a list, right? So the next object in here within software information, this is actually a list. Now, it's a list of just one object, but it is still a list. So we have a couple of different things that we can do for this here. We could write a for loop to iterate over this list, and that will absolutely work. But that doesn't really make sense in our case because we're just working with one object inside of that list. And if you, actually, let me just ask, can you recall how to reference the first object in a list in Python? That's right, it's the 0 index, right? So let's go ahead and return back to our script, and let's say give us the show version, software information, but give us the 0 index. Now in our script, we can absolutely get away with this because there really is only one object inside of here. Automation, Juniper123. But if you had multiple routing engines or multiple, maybe if this was like an MC lag or a virtual chassis, you could get multiple different objects that came back from this, just so you know. In our case, our firewall's just got a single routing engine. It's not clustered, nothing like that. So we're only getting back a single entity from each one of our devices. All right, so now we're digging through a little bit. We're stepping through this dictionary to find out what's the object that represents our operating system. All right, very well. Let's go ahead and just copy this new dictionary. I will paste it into here. We'll format it again. And now I can see that we're working inside of another list. It looks to be a list with a single dictionary. Again, the data model that's available, the JSON data model that was sent back to us was meant for, to cover both use cases of a single device, multiple devices, devices clustered together, multiple devices with multiple routing engines. So we kind of got to step through this. So if it's a little confusing, don't be afraid. All right. So the first thing that we want to look at is we're working inside of this object right here. It's a dictionary. And what we want to see is, I want to see the software version. So let's go ahead and key in on Junos-version within here. So we'll call for the key of Junos-version. Don't worry, just because there's a hyphen in here, it's not going to confuse Python with doing that subtraction because we've wrapped that hyphen inside of quotes, so it knows not to perform that type of operation. Let's go ahead and hit the save button, and we will run our script again. Automation, Juniper123. And what we should get back is a much more condensed version of the payload from our devices. All right, so now we're very, very close. Now we can see the version that's coming back, but the payload is now a list with a dictionary embedded in that list. Now that list, again, just a single object, but it's still a list. So we have to dig into it. And the way that we can do that is either looping over all the values within the list, which would make sense if there was more than one, or in our case, we can just reference again the zero index in here and hit save. And let's go ahead and hit the up arrow and automation Juniper 123. Now what I'm expecting back is simply a dictionary with the key of data and the value being equal to the operating system version that's running on our device, which is exactly what we see here. Now, we already know, looking at the payload above here, one of these things is not like the other. We've got one firewall that's running 18.4, while the other two are running 19.4. So let's go ahead and make this declaration right now that our golden image is supposed to be this 19.4 R3-S1.3. So what we'll do is we'll go ahead way above our loop at the very beginning. Let's create a new golden image object, and we'll set it to the value of 19.4. There we go. Okay, so now we have an object. It's set to the string value of 19.4 R3-S1.3. I'm gonna run out of breath if I keep saying that over. All right, now we have everything required for us to create an evaluation criteria. So let's go ahead and say, let's go ahead and create our first if loop, or our first if conditional. If, and we're gonna set it equal to this string, or this line of code right here. And then let's also dig in to make sure we get the key in on the data. So let's key in right here on data. Oops, data. All right. So if show version, and then we're working way through that dictionary, software information, zero index, Junos version, zero index, data, and then that will reveal the actual value of the operating system. If that is equal to, and you'll notice that we're using double equal signs here, and I'll type in the word or the object golden image, and then we'll hit the colon to actually create this nested operation. Again, we want to take some action if the result is true and another action if the result is false. So what we'll say is print this device is running the golden image, and anything else, we'll go ahead and use the else key for this conditional and say this device is not running the golden image. Now, again, we're using the double equal signs as part of our conditional. This is a mechanism for us to say, evaluate what's on the left-hand side of these equal signs with what's on the right-hand side of the equal signs. If we had just set the conditional to a single equal sign, Python's going to get confused and think that you're trying to set one thing to the other. You're trying to create an object and set it to the value of the other. That's not what we're doing. We're doing a conditional, which is an evaluation, so that is double equal signs. You may also see more commonly, you might see maybe greater than or equal to. You might see less than or equal to. There's all kinds of different conditionals that are available for us. In this case, we want a perfect match. And so that should be enough. Let's go ahead and remove that last print statement. I think this is going to be enough for us to be successful. Let's go ahead and run our script again. I'm going to say the username is automation. The password is Juniper123. And we should get back now whether or not the device, the firewall, is running the golden image or if it is out of compliance. Now, one thing that we are not accounting for is we're not providing a very intuitive way of sharing what that device name is. And I'll cover that in just in a second. How to get the device name and put it within this string right here, because this is helpful for you and I as we work through the development, but somebody that is operating this, at some other time down its life cycle will not know, hey, that third one that's not running the golden image, what was that device? What was its host name? So, first of all, let's get rid of the grammatical error. This device is not running the golden image. Okay, so right off the bat, our conditional works. We've been able to evaluate the current version of the operating system by digging through that Python dictionary that we got back from our RPC call. We found the key that represents the value of the operating system, and now we've done this evaluation by using the double equal signs and then calling back to our golden image string that we had created up there. Now for the last step, let's go ahead and get the let's get the host name of the device to be printed out with the rest of this string within our if conditional. Now the way that we can do this in the more recent version, and the only one that I'll cover today, is something called an F string. And what that allows you to do is basically insert a variable into a string and have that variable spelled out entirely, rather than trying to hard code it or some other kind of operation that wouldn't be appropriate. So the way that we create an F string is by pressing the letter F in front of a string and then using a single curly braces open and close, and then typing the name of our variable. In our case, that's just going to be the temporary name, or the temporal variable, ephemeral variable of firewall. And then we can remove that. And then we can do the same right here. So the expectation is that the firewall's name will be inserted into the string. Now let's see whether or not that is accurate. Automation, Juniper 123. All right, let's see how this comes back. So alderon.dmz.home is running the golden image. It's running the 19.4. We've evaluated it. And then Hoth is going to return back to say it is running the golden image. And then the last one is going to be Deep Space Nine, and that's going to be the one that's not compliant within our script. Great. Last thing for us to do, just make the output just a little bit prettier, because right now the only thing that we're getting back is everything is on the same, or it's separated by a single line, and I'd rather it to have just a little bit extra flair on it. So let's go ahead and add an additional line right up here, and we'll say we want the string. Let's go ahead and delete this. There we go. We want an equal sign, and I want it multiplied by 64. Now you might be thinking to yourself, that's an invalid operation, but you're incorrect. You can absolutely have a single character and multiply it by 64. You would just get a combination of 64 of that specific character repeated. You get that single character repeated 64 times. You cannot do addition, or you can't do a mathematical equation where we mix and match different integers and strings and etc. But we can absolutely use operations like this to just kind of help us get some additional flair within our output here. So let's go ahead and run this again. Automation and Juniper 123. And what we should get now is a nice little banner of equal signs, and then it'll actually say the name of the device and whether or not it is compliant. And there we go. So this will help us humans as we interpret the output that comes back. Sometimes it's nice to be friendly to your fellow humans, and this is one way that we're giving back. So there we are. Nice little separation in between the host names so that we can quickly identify what is compliant and what is not. So just like that, it didn't take too long for us to walk through the creation of a software compliance tool on the Juniper firewalls. We covered quite a bit today. We talked about why Python was important for networking engineers, mostly because of the ease of use, but also because of the packages that are available within the ecosystem. We talked about the different data types. What's a string? What's an integer? What's a list? What's a dictionary? We showed how those can be combined within a single script to give us our compliance code. We talked through the importance of installing and importing our packages. Again, just not necessarily just to be lazy, but to make our lives just a lot better by reusing code that's already out there. And then we talked about creating loops. We talked about the relationship with loops and lists together. And then finally, we talked about the conditionals, how to incorporate logic within your script. Now, don't run off and go update your LinkedIn profile as some kind of Python automation guru. There's still a lot to be learned. It's difficult to take an entire career and boil it down into like an hour's worth of content. There's so much to learn. In fact, the one thing I'll point out right here, one thing that you may have noticed is the speed of Python. Just kind of wrapping up, just talking about where to go from here on out. One of the things that I would start looking at is automation frameworks, tools like Ansible, Nornir, NetPalm. How do those devices help not only the development of our code, but also help with the speed in which that we're running in? Because Python inherently is a little slow. It's not a bad thing. It's still faster than humans, but there's a lot of room for improvement, and that's where automation frameworks really kind of shine. They also shine in other ways, such as working in a group context. But that's a whole other conversation for another time. For now, again, my name is Calvin Rimsberg, and thank you for hanging out with us while we learned some Python for networking and engineers. Have a good day.